Hey, Team B.A.D here. With the growing need for green, renewable energy, solar panels have become commonplace. Large, multi-paneled arrays have been made to match that increasing demand. With their size, however, they can be fickle. Power received depends on the entire circuit working, so a single malfunctioning panel impairs the entire system. Each panel has to be checked individually by a qualified technician, and carefully, as dealing with such a large voltage is dangerous. Not to mention, during that time the entire array is out of commission, with no power generated during the checking. That is tedious. We seek to automate that process by attaching a module to monitor each panel and wirelessly alert the user where the fault is the instant it happens.
Cristiano here. For the hardware component of our setup, we will have two solar panels that we will collect current and voltage readings from. These readings will be stepped down using a measured buck converter and large resistive loads so that they can be fed into our Arduino board. We will also need to collect solar radiance. This will be done by using a light diffuser combined with a photocell that will be calibrated based on the testing location. Safety is also a primary concern of ours, as these equipments will produce over an amp of current, so shielding and fuses will be used to protect both the equipment and the team members.
I am John Navis. Besides hardware, the other main component of this project is the software aspect, which involves machine learning and signal processing. As Cristiano mentioned, we'll be measuring many key features from our solar panels such as voltage, current, irradiance, and temperature. We will then be using machine learning algorithms to take this data and determine how well our solar panels are performing. So it will determine if it's operating under standard testing conditions, if it's in a shaded region, if it's dirty, if it has signs of degradation, or if there are major errors in play. We have met with PhD students who have worked with our director at SenSip in the past on solar and machine learning projects. We have discussed using many different machine learning algorithms such as logistic regression, support vector machines, artificial neural networks with varying amounts of hidden layers, as well as k-means clustering. Since our panels right now are not up and running, we are using a public dataset of over 20,000 observations of solar panel users from Cyprus, and so our plan right now is to take this dataset, we'll train and test our models with it, and then once our system is up and running, we will apply these weights and this model to it, and we'll make changes as need be.
Hey, Richard here. After the code has processed the data, it will send it to a downloadable application. On this app, the user can easily see voltage, current, and power consumption of each solar panel. If something is wrong with a panel, the user will be notified that action is needed to improve the panel's performance. This application will be developed alongside the main processing code, yet should be completed before so the processing code can be tested. Cristiano and I will tackle the hardware as well as the GUI, while Alex and John develop the main code. With all of these components coming together, the worry of a malfunctioning panel is reduced. This has been Team B.A.D with the future of monitoring solar panel arrays.